You might have seen clips of 1X's Redwood robot calmly folding laundry or picking up clutter. But behind the scenes, something even bigger has happened. 1X recently updated their bipedal humanoid, NEO, and this time, it's no longer just a research bot on training wheels. They've integrated their Redwood AI model directly into NEO's architecture. And that move? It shifts NEO from a teleoperated prototype into a fully autonomous, learning-capable machine. Now, for the first time, NEO can perceive, reason, and act independently and in real time. All of its core decision-making happens on-device, thanks to an upgraded GPU setup and optimized control stack. That's huge. No reliance on cloud servers means faster reflexes, more privacy, and greater reliability. Exactly what you'd want from a robot working around humans in a dynamic space like a kitchen or living room. But here's where it gets even more interesting. This isn't just plug-and-play AI. NEO learns from its environment and its own past mistakes. If it fails to pick up an object, it tries again, refining its behavior using reinforcement learning loops. It's not memorizing moves, it's building a mental model of how the world works. And that mental model is getting supercharged by something called the 1X World Model. Now, this is where things get next level. The 1X World Model is essentially a highly specialized, data-driven simulator built specifically for humanoid robots like NEO. It's not your typical game engine. It's grounded in real-world physics and trained on terabytes of sensor data from actual robot interactions. What does that mean in practice? It allows NEO to simulate, or hallucinate, future outcomes before taking action. Every movement, every object interaction, every environmental change can be mentally rehearsed internally before anything physically happens. So instead of NEO just reacting moment to moment, it can actually predict how its actions will play out. That turns it from a reactive system into a forward-planning agent, capable of reasoning like, if I move my hand this way, will I knock over the glass? What if I adjust my grip angle by 5 degrees? And it's not just about making the robot smarter, it's about making development faster. With the world model, 1X's engineers can instantly evaluate how well a new AI model or behavior performs, without needing to run a full physical test every time. That compresses development cycles, helps benchmark generalist skills, and accelerates iteration across the entire robotic stack. Take a look.
Evaluating the quality of a model is a long-standing challenge in robotics. This makes it incredibly difficult to define a clear path towards improving autonomy. Currently, evaluating a general-purpose AI model requires running physical trials across the full spectrum of scenarios it might encounter. This corresponds to a lifetime of experience in the real world. That's why we built the 1X World Model, which serves as a bridge between atoms and bits. The world model is a digital twin of the real world that predicts the future consequences of a robot's actions. This deep generative neural network allows us to compress that lifetime into an instant.
The 1X World Model tackles the complexity of the real world by learning directly from thousands of hours of robot interaction captured from raw sensory data. This enables us to model complex physical interactions, such as the grasping of delicate objects, collisions between rigid bodies, and the deformation of objects when manipulated, giving our model a firm understanding of the physics of the world around us. As we scale up our data, especially from interesting failure modes where NEO's task execution doesn't go exactly as planned, we find that the quality and accuracy of our world model reliably improves. This pattern of improvement mirrors trends observed in other large generative models, where the capability of the model scales with collecting the right type of data.
Practically speaking, we leverage the world model to quickly assess and compare across many different policies. With a general model like Redwood that is trained to handle many different tasks across different environments, the world model lets us evaluate its capabilities with measurable results, shortening our iteration speed from weeks to minutes.
Here at 1X, we've experimented with different modalities and sources of data, including web-scale video data, first-person perspective human data, and teleoperation. But we found that the most important type of data for scaling up the capability of our world model is Neo autonomously interacting with real environments, attempting real tasks, and succeeding and failing in interesting and diverse ways. We are only able to collect this data at scale because Neo is a safe and compliant robot capable of continually running in unstructured environments.
Beyond just evaluation, the world model can fundamentally change how Neo approaches decision-making. By continuously visualizing future states, Neo can effectively use the world model as its cognitive core, dynamically planning and adjusting its actions based on predicted outcomes. This predictive capability allows Neo to execute tasks more successfully, adapt more quickly, and handle unexpected events gracefully, bringing us closer to truly intelligent, general-purpose robotics.
In short, Redwood gives Neo the brain to act on its own. The world model gives it the foresight to act intelligently. Together, they're building toward a future where humanoid robots aren't just tools. They're collaborative, adaptive partners that can safely operate in the same environments we do.